All right, let's go over this last problem here before we do a little bit of math on the next page. But this was a good multiple choice question that I kind of broke down and put some explanations on each answer choice. So let's make sure you understand what's happening here. All right, so several factors are involved in the creation of a confidence interval. Among them, of course, are the sample size and then the confidence level, which then combine together to make that margin of error. Okay, so we know that. So, is it true that for a specified or a set sample size, so if n stays the same, then a higher confidence means a smaller margin of error? Okay, so I have to think about these things. Okay, so let me see here. So, if n stays, so I got to write on this. If n stays the same, so if n is staying the same, so then this is the same. Then they say higher confidence. Okay, so higher confidence. So that means here's 95%, 99%. Higher confidence is a wider, a larger interval. Okay, so that's false. All right, how about this? Is it true that for a specified or a set confidence level, so if Z star stays the same, that a larger n, so this stays the same? Is it true that n, as n gets bigger, then that smaller margin of error? Yes, that's true. Because I know as n gets bigger, this standard deviation gets smaller. So that, okay, cool. Got that down. All right, next one. Is it true that a larger sample, okay, so n is getting bigger, and remember, n getting bigger means this standard deviation is getting smaller, so this is getting smaller. Is it true that larger samples allow you to have greater confidence and maintain the same margin of error? Okay, so this is going to be the same size. If this number goes down, then that will allow this number to go up. So, yes, so I can have greater confidence. Good. If this goes down, then this can go up. Okay. All right. Is it true that for a given confidence level, okay, so the Z star stays the same. Cutting the margin error in half, so that would be like making half of the margin of error, can happen if you make the sample size twice as large. Okay, this is perfect. It leads us right into the next page, right into the next part, and that's no. If this is half, then, then of course this side would have to be half. Well, that's not true. What comes out, you are not making the sample size twice as large, you're making the sample size 4 times as large. 4 times as large is what comes out as a half and makes the margin of error half. So it's 1 over the square root of what that change is. And so that is exactly what we see here. Let's investigate the relationship between the change in sample size and the change of the margin of error. So make the sample size 4 times larger. So you can see here I put a 4 right here. Then if I put a 4 here, that is like 1 over the square root of 4 pulling out, or really it's square root of 1 over 4. So that is a half. So if I put a 4 here, that's the same as putting a half on the left side. All right, if I put a 9 here, then the pulling it out of the square root is a third of the margin of error. 16 times larger is a fourth of the margin of error. Okay, so now try this next 2 questions here. Okay, so this one is saying we have a simple random sample of 9,000 viewers. Okay, so that's what we start with. But assuming the sample proportion does not change, so everything else is staying the same, what's the change in the width of the confidence interval of the second 95%? So the Z star stays the same if the sample is only 1,000. Okay, so the second one has a smaller. So this is the opposite, right? So N got smaller. So N got smaller. If N is getting smaller, then the margin of error is getting bigger. So so it's getting 1/9 of the size, then this is going to be 3 times because you multiply by that reciprocal. Okay, so that's 1 over 1/9, square root of 1/9. Anyway, so that's what's happening. So let's see. We started with that 9,000. It became 1,000. So N is 9 times smaller. So the standard error will get, the margin of error will get 3 times bigger. Not 9 times bigger, 3 times bigger. Okay, let's try the next one. So here I had to pay attention to what was going on. So X was size 100, Y is size 400, so Y is 4 times bigger than N. So Y is 4N. So Y is the one that is 4 times larger. So Y is gonna have half the margin of error that X does. So what happens is when I go look at all my answer choices, it doesn't give me that option. It talks in terms of X. So Y has half of the margin of error, means X is twice the margin of error. Okay. So you've got to really pay attention to which way does it go. Is that the last one? Yeah. All right. That's the end of what all's going on with these confidence intervals and confidence level and all that kind of stuff. I think that tomorrow we just put it all together and you warm up so that you can quiz on Thursday. Confidence intervals.